everyone. In this video, we're going to look at an overview of metabolism and the role that it plays in cells. If I say the word metabolism to you, you probably already have some idea of what it means. In biology, we talk about metabolism in terms of the sum of all of the chemical reactions in an organism. These chemical reactions can be considered in terms of their effects on matter, with anabolic referring to reactions that build larger molecules from smaller pieces, and catabolic referring to reactions that break things down into smaller components. If you're having trouble remembering which is which, I tend to think of all those videos of cats pushing things off shelves and breaking them. The other way we can classify our chemical reactions is in terms of energy, with exergonic reactions being those that release energy, and endogonic being those that require an input of energy. Catabolic reactions tend to be exergonic, and anabolic reactions tend to be endogonic. Gibbs free energy, often just referred to as free energy, or G, is the amount of energy in a system that is available to do work. In a chemical reaction, we consider the change in free energy, or delta G. That is, the amount of free energy in the products minus the amount of free energy in the reactants. And whether this gives us a positive or negative number will tell us whether the reaction will be spontaneous or not. Spontaneous reactions are those that will proceed unaided. However, that doesn't mean that they are fast. Some can take years to occur, and so a cell may need to speed up even spontaneous reactions to make them happen at a rate that will be useful. And we'll look at that more in the video on enzymes. We're going to start here with an exergonic reaction, that is one with a net release of energy. On the y-axis of our chart here, we have delta G, and on the x-axis we have time. In our exergonic reaction, the amount of energy stored in the reactants is higher than that in the products, resulting in a release of energy and a negative delta G, telling us that the reaction will be spontaneous. Now, let's consider an endogonic reaction. In this case, the amount of energy in the reactants is less than that in the products, meaning we have to add energy in to get the reaction to happen. So in this case, delta G is positive, and so the reaction is not spontaneous. To make endogonic reactions happen, cells put energy in, usually in the form of ATP. You can think of ATP as batteries for a cell, and this cycling between ADP and ATP is akin to depleting and recharging the batteries. In a cell, exergonic reactions provide the energy to build the ATP and charge the batteries, while endogonic reactions require hydrolysis of ATP into ADP and phosphate, depleting the batteries. In a cell, this energy is usually provided by breaking down food during cellular respiration, which occurs in the mitochondria, and provides energy for all of the things that an organism needs to do, like movement from muscle contraction, biosynthesis of macromolecules, transport of molecules inside and out of the cell, and even making new cells by cell division. In this way, ATP can be used to couple exergonic reactions to any of a cell's endogonic energy-requiring processes. Thanks for watching, and please make sure to check out the video on enzymes.